Now, what do you understand by strain? I have already told you. He is right in the more long definition. Simple meaning displacement per unit length. Okay, displacement per unit. Displacement means change in length. Last time we had already discussed delta L. This is the delta L upon original length. That is called the strain. And it is in meter or mm. It is also in meter or mm. So meter or mm cancel out. So it is the unit less quantity. This is the unit less quantity. Okay, da? This is the unit less quantity. Yeah, it is remember. It should be remember. It is the unit less quantity. Question always asked in objective questions or in the very short questions. You should what is the define the stress strength. So you should write the displacement per unit length is called strain, and its unit is you define the it is the unit less quantity. Okay, so strain basically nothing but a displacement or change in length upon original length. He will not write here original length, but it will be a particular length or original length. So basically, in definition, linear strain or simple strain is called change in length upon original length. How it is depend on strain is the linear strain, volumetric strain also aerial strain depend upon the cross section area and particular components. So it will be depend upon the areas. So here he write there the no material is perfectly rigid itself. Correct? Because no material is perfectly correct. So in the word, everything basically you consider so no material is perfectly rigid. There is some elastic mixture of the elastic and rigid, but no material is perfectly rigid or not perfectly elastic. In your word, in the real word, no material is perfectly rigid, no material is perfectly elastic, and no material is perfectly plastic. Clear? So, under the action of force, a rubber undergoes changes in the shape and size. Rubber basically have some elastic body. Okay, so this phenomena is a very well known to all the since in case of rubber. Even for the small forces, deformation are quite large. Actually, all the materials, including steel, cast iron, brass, concrete, etc., undergo similar deformation when loaded. Steel is more elastic than other components. Steel is more elastic than rubber, than cast iron, than brass, etc. So steel is more elastic. So, but deformation means displacement. Means deformation means displacement or extension. Okay. So deformation basically are the very small and hence we cannot see them with naked eye. So there are instruments like extensometer, electric strain gauge, which can measure extension of magnitude like 1 by 100, 1 by 1000, 1 by 10,000, okay, or of the millimeters. So there are machine like, what do you understand machine? There is a word mentioned is machine. You know machine? Everyone know machine. Machine basically is defined as it is the assemblage of several components for the purpose of transforming external energy into useful work. That is called machine. Machine is nothing but machine is the assemblage of several components for the purpose of transforming external energy into useful work. That is called here machine. And you know mechanism. Basically, you know mechanism. Mechanism is nothing but it is fixing the link to the ground. You obtain the mechanism. Now, this is the mechanical part, but we want to discuss in the only stone part, means only the solid mechanics part. So there are machine like universal testing machine, UTM machine, okay, in which bars of different materials can be subjected to accurately known forces of magnitude as high means as 1000 kilonewton, 2000 kilonewton, 4000 kilonewton, etc. So here the studies have shown that bar extend under the tensile force, okay, and shorten under the compressive forces. Both conditions are applied in UTM ultimate tensile extent machine, means consider tensile also compressive. Both stress are up, uh, uh, you consider in the UTM machine, perform the UTM machine. So here in the diagram, the change in the length per unit length is known as linear strain. So according to me, displacement per unit length or deformation per unit length in one line, you should remember only. Remember, displacement or deformation per unit length, that is called linear strain. But you should define displacement per unit original length or particular length, that is called the linear strain. Okay, so this is similar figure has applied. Suppose we last figure we have see the diagram. You apply the forces. This is the tensile force. Suppose tensile force applied. So this length is increased and this is decreased. This width is also decreased. Area decreases. If you apply the tensile forces, okay, length increases but area decreases. In that cases, you consider in that cases. So this is the dash dash. This is the original. Original dark continuous and dash dash after elongation takes place delta L. So suppose this is the dark component and continuous component is the original. After applying the load P, means extensive force P. So this component is stretched. This component is stretched, it goes to here in that manner. So this is delta. Also, this length also contract. This is also contract. This is also contract. We obtain the dash bar. Dash bar is the after the load applying. We obtain the extension. Here extension in extension delta L. Area also reduces. Area also increase basically because here this is the area, okay, original area, and then this length also decrease, this gap also decrease, this gap is decreases here, this gap is decreases. So area you can decrease. So this is the original length, and after the shortening, now we apply the suppose force P or P1, that is the compressive force, or simple we can say that C, compressive force. Okay, you can see tensile forces also. Okay, this tensile forces is the compressive forces. So suppose you apply these forces. After applying the forces, this wall reaches at this dash point. But here this length also bulge outside. This length also bulge outside. This length also bulge outside. But here this length goes inside and this length goes inside. So crossing area decreases. In that case, crossing area increases here. So here, shortening the component. So this is the dash dash component. After dash dash component, here area increase, here area decrease. Okay, that is the front view. This is the front view, and this is the side view. If you see in that direction, this is your eyes. Okay, okay. This is the eyes. So see in that direction. So you obtain only the rectangle, it's square shape. Okay. So in that case, dash area decrease. This is the area decreases here. Okay. Now in that cases, dash area outside. This dash line outside the country line. Here area increases. Area increases. Okay. So after shortening, area increases. After elongating or extension, area decreases, but length increases. Okay. So now in that cases, we define which changing in the longitudinal direction is taking place, changing in the lateral direction also. take place. Means longitudinal in x direction, lateral in y direction. Simple meaning. Okay. There is no confusion. In x direction, simple meaning linear. Okay. Linear things or longitudinal. Linear or longitudinal. Okay. This is longitudinal. And in y direction, this is the x direction. This is the y direction. So this is the transverse or lateral. Okay. Transverse or lateral you can consider or transverse. Okay. So in that cases, nature of these changes in the lateral direction are exactly opposite to that of changes in the longitudinal direction. If extension means elongation, if extension or elongation is taking place in the longitudinal direction, means x direction, the shortening of lateral dimensions takes place. And if shortening is taking place in longitudinal direction, then extension takes place in the lateral direction. It is vice versa. Okay. So lateral extent may be defined as the change in the lateral direction per unit lateral dimensions. So here lateral extent basically the change in lateral dimension upon original lateral dimension. Or longitudinal means here I have already defined this is the longitudinal strain change in length upon original length. Okay. So this is the lateral strain means B dash minus B upon B. Here, this is the B dash. In that cases, B dash is bigger dimension. B dash is bigger dimension minus B small dimension. B dash minus B dash. B dash minus B upon B. So this is the delta B upon B. This is the basically lateral extent. Now we want to take the contraction. In that case, contraction B dash minus B upon B. This is a negative means delta B. So we obtain a minus delta B upon B. Okay. Suppose B, this is the extension. Now we taking the contraction or shortening. In case of shortening, so this is the minus delta B upon B because this is the B dash minus B upon B. But B dash here is less than B. So this is the negative. Negative minus delta B upon B. In that cases, when contraction or shortening takes place, then this is the B dash is small. This is the B dash is small. Okay. This is the B dash. This is the B dash. And this is outer dimension is the B. So B small B dash is here. In that cases, B dash here this C less than B. Okay. Now in extension cases, B dash is greater than B. See here, B dash greater than B, here B dash less than B. Now, so here we obtain contraction means minus delta B upon delta B, delta minus delta B upon B. That is called the contraction. And here uh, delta B upon B, that is the positive means extension. Here we obtain extension. In that case, we obtain extension. And in that case, we obtain contraction or shortening. It is the contraction. Okay. Contraction or shortening. Okay. SHORT, shortening. ENING. Okay. So contraction or shortening obtained in that case because B dash less than B means B dash minus common means delta B upon B is the contraction. In that case, B dash is positive, so B dash minus B upon B means B dash minus B is called delta B dash upon B. So delta B upon B is a extension. In that case, contraction. I think both things are same because they are depend only positive and negative. Positive and negative. Here negative and here positive. But only difference is the positive and negative. Now, I think concept is clear.